Hello, you're welcome to our mathematics class. And in mathematics, we shall be looking at the topic permutation and combination. Now, what does permutation mean? Permutation is simply an arrangement of objects in a particular order. For instance, if you have a blue marker, in how many ways can you arrange a blue marker? You can only arrange it in one way. And so we have, since it is one way, we have it as 1 factorial. 1 factorial means 1, right? Now when we have two markers, let's say we have a blue marker and a black marker, in how many ways can we arrange these two markers? We could either make the black come first, or we could make the blue come first. Is there any other way we can arrange it? No. And so because of that, these markers, that is blue and black, can only be arranged in two ways, which is 2 factorial. And 2 factorial means 2 multiplied by 1. So now, let's introduce a third marker. Let's introduce a red marker. Here is a red marker. Now, if you are going to introduce a red marker, where are the possible ways we can introduce the red marker? It is either we introduce the red marker here, or we introduce red marker here, or we introduce red marker here. Making how many ways? That's 3 ways. We could also introduce the red marker here, or here, or here. Here we have another 3 ways. So we have 3 plus 3. And so when we have 3 markers now, we'll find out that we have 6 ways. And how is this done? Since we have 3 markers, that is 3 factorial, which is equal to 3 multiplied by 2 multiplied by 1. And so that gives us 6 ways. And if we have more than 3 markers, let's say we have up to 10 markers, it means that we can't start arranging just like this, but we have a simpler formula which we can use for calculating it. And so we have a general formula which we shall apply to solving questions on permutation. In the case where we have r objects out of n objects, a formula which is n permutation r. N is the number of objects which we have, and we are told to select r out of the n objects. That is, in how many ways can we arrange it? And so this formula is equal to n factorial over n minus r factorial. We'll look at the application of this formula in a while. Alright, so next we will introduce combination. Combination is basically interested in the number of selection possible, not interested in the order or arrangement. Alright, so let's look at the first case we have. So what is combination about? It is basically interested in the number of selection possible, not interested in the order or arrangement. So for instance, if you have a black marker, right? There's no order or arrangement, there's no selection. This is the only option that is available. So we can't do anything about this. Now when we have 2 markers, we have a black and we have a red. Alright? Now, in how many ways can we select these 2 markers at the same time? We have just one way we can select it. We are not interested in which one comes first or which one comes last. The important thing is that we want to select 2 markers out of 2 markers, and so we have just one. So we have just one way of choosing. Next, if we introduce a black marker, a blue marker, and a red marker. Now with this, if we are told to select 2 markers out of these 3 markers, in how many ways can we select or choose 2 markers out of these 3 markers? Now I want you to take note that we could either say that we'll choose black and blue. We could choose black and red. We could choose blue and red. And so we have exhausted all the selection we can have. We can have black or blue, black or red, then blue or red. So we have 3 ways. So we have 3 ways of choosing in these aspects. So take note that if you have blue coming first and then black coming second, it is the same thing as saying black and blue. If you say black and red, it's the same as saying red and black. If you say blue and red, it's the same as saying red and blue. Now with this particular arrangement, where we have more than 3, then it may become complicated. And so because of that, we have a formula which is introduced, that n combination R equal to n permutation is equal to n permutation R over R factorial, or n factorial over R factorial bracket n minus R factorial. And so we can use this formula to solve questions that relates to combination. Alright, so let's take this set of questions. We have to evaluate A, 4 permutation 2, B, 6 permutation 3, C, 4 permutation 3 over 3 permutation 2. Alright, so let's work on the first, which is 4 permutation 2. We have a formula that says n permutation R equal to n factorial over n minus R factorial. In this case, n is 4, so we have 4 factorial over n minus R, where n is 4 minus R, which is 2 factorial. And so we have 4 factorial, which is 4 times 3 times 2 times 1, over 4 minus 2, which is 2 factorial itself. And that means we have 4 times 3 times 2 times 1 over 2 factorial means 2 times 1. So 1 cancels 1, 2 cancels 2. So we are left with 4 times 3, we have 12. There are other ways we can easily solve this. We could say that 4 permutation 2 is equal to 4 into brackets 4 minus 1. What does this stand for? Since we have to select 2 out of 4, we are looking for a number of ways of taking 2 from 4. So the first one is 4, and then the second one is 4 minus 1. So we have 4 multiplied by 4 minus 1, that gives 3. So 4 times 3, that gives 12. Alright? The B part says 6 permutation 3, and that is applying this formula. The 6 is n, so we have 6 factorial over n minus R, where our n is 6 minus 3 factorial. I want us to look at a simpler way of getting this done. Now 6 factorial over 6 minus 3, that gives 3 factorial, right? So 6 factorial is same thing as 6 times 5 times 4 times 3 times 2 times 1. Now instead of going about doing all that, you can just write 3 factorial. Since 3 factorial means 3 times 2 times 1 over 3 factorial. And so 3 factorial cancels 3 factorial. And so you are left with 6 times 5 times 4, and that gives 120. Take note that you could solve this particular problem like this. How would that be done? Since you have to choose, you are looking for how many ways you can choose 3 from 6. And so we have the first, which is 6, multiplied by the second, which is 6 minus 1, multiplied by the third, which is 6 minus 2. And so with this, you have 6 multiplied by 6 minus 1 gives 5, times 6 minus 2 gives 4. And when you multiply this out, you have 120. So you can have ways depending on what the question is about. Alright, so the third part of the question says 4 permutation 3 divided by 3 permutation 2. So what we need to do is to solve them separately. Where we have 4 permutation 3, it means this n, so we have n 4 factorial over 4 minus 3 factorial. And so we have 4 factorial over 4 minus 3 gives 1 factorial. 4 times 3 times 2, and that is 24. Then 3 permutation 2, that is 3 factorial over 3 minus 2 factorial. So with this 3 factorial, so that's 3 factorial over 3 minus 2, that's 1 factorial. And so 3 factorial is 3 multiplied by 2, and that is 6. So then we have to divide it. So we have 24 divided by 6, and that will leave us with 4 as the answer. Alright, so here's the next question. It says 5 students are staying in a dormitory. In how many ways can you allot 5 beds to them? And so in this case, we are looking for how many ways we can allot 5 beds. So this question is a permutation question. We have 5 beds, and so the first person, we can allot one of these beds. Now, before we allot one of these beds, how many options does the first person have? The first person could either be here, 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 or here. So meaning it has 5 options. Let's say the first person settles here. The second person has how many options left? 1, 2, 3, 4. So here, the second person. The third person has how many options left? Here. So he has 1, 2, 3. So we have times 3. So let's say he settles here. We have 2 beds. Fourth person has 2 options left. So we have times 2. And then the last person has just 1 option left. And so that's equal to 5 times 4 times 3 times 2 times 1. And that is 120. This is same thing as saying 5 permutation 5. Right? 5 permutation 5, which is n factorial over n minus r factorial. That is 5 factorial over n, which is 5 minus 5. So we have 5 factorial over 0 factorial. We will take this out. So 5 factorial is going to be 120. Next question says evaluate A, 5 combination 2, B, 5 combination 3, C, 6 combination 3 divided by 4 combination 2. Alright, so we take the first one, which is 5 combination 2. We have a formula that says that 5 combination 2 equal to n factorial over r factorial to bracket n minus r factorial. In this case, n is 5, so we have 5 factorial over r factorial, which is 2, to bracket 5 minus 2 factorial. And so we have 5 factorial over 2. 2 factorial means 2, right? 5 minus 2, that gives 3 factorial. And so we have 5 times 4 times 3 factorial over 2 times 3 factorial. So 3 cancels 3, 2 cancels, we have 2. So 5 times 2, that gives 10. That is the answer. The B part says 5 combination 3. We use this formula where n is 5. And so we have 5 factorial over r is 3. So that's 3 factorial into bracket 5 minus 3 factorial. From here, we have 5 factorial, which is 5 times 4 times 3 factorial. Alright? Over 3 factorial times 5 minus 3, that's 2 factorial. 3 factorial cancels 3 factorial. And so we have 2 factorial left here. 5 times 4, we have 20 over 2 factorial, which is 2. So 2 cancels 10. 20, we have 10. And so the answer is 10. We move on to the C aspect, which is 6 combination 3 divided by 4 combination 2. So let's go ahead with the first part, which is 6 combination 3. N is 6, so we follow this formula, which is 6 factorial divided by 3 factorial into brackets 6 minus 3 factorial. Now that's equal to 6 times 5 times 4 times 3 factorial over 3 factorial multiplied by 6 minus 3, that gives 3. So we have 3 factorial. 3 factorial cancels 3 factorial, right? And then we have 6 times 5 times 4. Now take note that 3 factorial means 6 times 5 times 4 over 3 times 2, which is 6. So this cancels this. We are left with what? 20, right? And next we have 4 combination 2, which is same as 4 factorial over 2 factorial into bracket 4 minus 2 factorial. So we have 4 times 3 times 2 factorial over 2 factorial times 2 factorial. 2 factorial cancels 2 factorial. So we have 4 times 3, which is 12 over 2. So we have 6 left here. Next, 6 combination 3 is 20. So we have 20 here. And then we have 4 combination 2, which is 6. So we have 6 here. So when we divide this, 6, we have 2 here 3, 2 here 10. And so we have 3 odd number, 1 over 3 as the final answer. Here's the next question, which says, find the number of subsets of the sets 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, having 4 elements. Now, what does this mean? We want to have a subset of this set 1, 2, 3 to 11, and in the subset we need to have 4. So we need to pick 4 from this. So we have 1, 2, 3, 4. That's the subset. 1, 2, 3, 5. That's another subset. Now we want to look for how many subsets we can get from this particular set. Taking note that what we want to just do is to choose. We are not interested in arranging. And so if you have 4, 3, 2, 1, it's the same thing as 1, 2, 3, 4. Now in this case, what we are looking at is a combination. And so we have it as 11 combination 4. And what is 11 combination 4? We follow the formula, which is n factorial over r factorial into bracket n minus r factorial. N factorial, which is 11, over r factorial, which is 4 to bracket n, which is 11 minus 4. That's okay, factorial, right? So we have 11 factorial over 4 factorial multiplied by 11 minus 4. That gives 7 factorial. With this, we have 11 times 10 times 9 times 8 times 7 factorial over 4 factorial times 7 factorial. Now it's time to stop at 7 factorial so that the 7 factorial can cancel out 7 factorial. So 7 factorial cancels 7 factorial. Next we have 4 factorial here, which is, so when we multiply this out, alright, so we have this, that's 110 times 9 times 8 over 4 factorial, which is 4 times 3 times 2 times 1. And so 2 times 4 cancels 8. 3 here, we have 3 left there. And so 110 multiplied by 3, we are left with 330 subsets. And so we can have 4 of each of these arranged from 1 to 11. The next question, which says that in a box there are 5 black pens, 3 white pens, and 4 red pens. In how many ways can 2 black pens, 2 white pens, and 2 red pens be chosen? Now in this question, we're told that we have 5 black pens, we have 3 white pens, and then we have 4 red pens. And we are to choose such that we have 2 black pens, we have 2 white pens, and then we have 2 red pens. In order to carry that out, now when you look at this carefully, we want to choose 2 from 5. In how many ways will you be able to choose it? We want to choose 2 white pens from 3 white pens. And so what we are concerned here is basically choosing, not arranging. And so because of that, we have it as 5 combination 2. And then here we have 3 combination 2, 4 combination 2. We have a multiplication sign between them all. Now, 5 combination 2. Now we could easily use our calculator to solve this, but let's quickly use the formula. We have n factorial, which is that's 5 factorial over 2 factorial times, that's 5 minus 2, which is 3. So that's 3 factorial. Multiply by 3 factorial over 2 factorial into bracket. Then 3 minus 2, which is 1. So we have 1 factorial. Multiply by 4 factorial over 2 factorial. Multiply by 4 minus 2. That's 2. So we have 2 factorial over here. So from here, we have 5 multiplied by 5 multiplied by 4 times 3 factorial over 2 factorial times 3 factorial multiplied by 3 multiplied by 2 factorial over 2 factorial multiplied by 4 times 3 times 2 factorial over 2 factorial times 2 factorial. Here 3 factorial cancels 3 factorial, 2 factorial cancels 2 factorial, and then 2 factorial cancels 2 factorial. And so we are left with 5 times 4, that's 20, and then 2 factorial is 2, multiplied by 3, multiplied by 4 times 3, that gives 12. So we have 12 over 2 factorial, which is 2. So 2 here, we have 10, 2 into this, we have 6. And so 3 times 6 is 18, and 18 times 10 gives 180. And so we have the answer as 180 ways. Here's the next question, which says, a question paper consists of 10 questions divided into 2 parts, A and B. Each part contains 5 questions. A candidate is required to attempt 6 questions in all, of which at least 2 should be from part A and at least 2 from part B. In how many ways can the candidate select the question if he can only answer all questions equally well? Alright, so this is an interesting question. It says that a question paper consists of 10 questions, and then we have part A and part B. So this is part A and this is part B. We're told that each part contains 5 questions. So we have a total of 5 questions here, and then we have 5 questions here, making a total of 10. Then the candidate is required to attempt 6 questions in all, of which at least 2 should be answered. So he has to answer 6 questions, but at least he must answer 2 from A and 2 from B. Meaning that if he answers 2 from here, he can answer 4 from here, so that he will have a total of 6, right? He could answer 3 from here and answer 3 from here, making a total of what? 6. He could answer 4 from here and answer 2 from here, all still going to give us 6. Now we're asked that in how many ways can the candidate select the questions if he can only answer all questions equally? Alright, so from what we have seen here, here is the first part, here is the second part, here is the third part. Important thing is that he can answer like this, or like this, or like this. And because of that, it means that out of 5 questions, he can choose 2. Out of 5 questions, he can choose 4. What does that mean? When you are choosing like that, what we are talking about is combination. And so we have 5 combination 2 multiplied by 5 combination 4. We are having multiplication because it is an and over here. Because he has to do this and he has to do this to make it 6. That's for the first part. For the second part, he can decide to answer 3 from out of 5, and that will be 5 combination 3 multiplied by 5 combination 3, right? And then the third part, he could decide to answer 4 from out of 5, and so we have 5 combination 4 multiplied by 5 combination 2. Now with all this, he can answer anyhow, so either like this or like this or like this, and because of that or, it will bring an introduction of plus in between. Alright, and so what we need to do is to find 5 combination 2. So 5 combination 2 gives 10 multiplied by 5 combination 4, which gives 5, plus 5 combination 3, which gives 10 multiplied by 5 combination 3, which is also 10, plus 5 combination 4, which is 5, times 5 combination 2, which is 10. 10 multiplied by 5, that gives 50, plus 10 times 10 is 100, and then 5 times 10 is 50. And so we are having 200 ways. So we have 200 ways of answering questions in that order. Next question says, a senatorial candidate had planned to visit 7 cities prior to a primary election. However, he could only visit 4 of the cities. How many different itineraries could be considered? Now, when we're talking about itineraries, we are talking about routes that he could go, he could pass through, or the places where he could visit. How many of those cities are possible for him? Now, we are told that there are 7 cities, right? And he could only visit 4. How many would it have been possible for him to visit? And so in that case, now let's say that we have 7, right? Now, out of the 7, should he have visited this first, second, third, fourth? Now we are talking about the arrangement by which he could have visited it. So we're asking that how many different cities could be considered. And so we are looking at permutation. So we have 7 permutation 4, right? And so using our formula for permutation, which is n factorial over n minus r factorial. N factorial, which is 7 factorial over 7 minus 4 factorial. We have 7 multiplied by 6 multiplied by 5 multiplied by 4 multiplied by 3 factorial over 7 minus 4, that's 3 factorial. And so 3 factorial cancels 3 factorial. We are left with 7 times 6 times 5 times 4. And that produces 840. So we have 840 ways by which this is possible. Next question says, a committee of 6 is to be formed by a state governor from 9 state commissioners and 3 members of the House of Assembly. In how many ways can the members of the committee be chosen so as to include 1 member of the House of Assembly? So from here, we're told that we want to have a 6-man committee, and we have 9 state commissioner. So we have state commissioner, we have 9 in number, right? And then we have 3 House of Assembly members. So we have House of Assembly members, we have 3 of them. In order to form 6, now the question now says that at least there must be 1 member. Okay, it says that this 6-man committee that we want to choose, we want to have, there must be just 1 member of the House of Assembly. And so if you have 1 from 3 here, we'll have 5 that must have been selected from here, right? So from here, it means that we're having 5 from 9, which is a combination question. And so we'll have 9 combination 5 multiplied by 3 combination 1. And so 9 combination 5, that gives 126 multiplied by 3. And so when we multiply this out, it gives 378 ways. I think we were asked to find the number of ways that the member of the committee can be chosen without telling us any particular number of House of Assembly members that should be there. So what we could have done would have been to have that we could say that this is 1 way, right? We could have a second way by having 2 House of Assembly members and 4 to give us 6. Or we could choose the 3 from the House of Assembly and choose 3 from here to make the 3rd way. And then this 3 plus 3 will give us 6. So what we would have done is to find the combination of this times this plus the combination of this times this plus the combination of this times the combination of this, and that would give us something else. So but in this case, this is what we have as the answer. Next question here says, how many possible ways are there of seating 7 people, P, Q, R, S, T, U, and V, at a circular table? So let's have a circular table here. We want to fix 7 people on this table. There is no relative position on this table, and so we could place the first person anywhere. Let's assume that we'll place the first person here. That is out. We have 6 people left. Now we could place the second person either on the left of the first person or on the right of the first person. We could place the person on the left side of the first person or on the right side of the first person. And in that aspect, meaning that there are going to be 6 options left for the second person. So we have 6. Then for the third person, since we have 2 spaces out, we have 5 left for the third person. And so we have times 5. Next is times 4, times 3, times 2, times 1. And so what we are saying now is that when we talk about a permutation such as this, where we have a circular table, what we need to do is that if we are given a number of people that are going to be there, what we need to do is to say number of people minus 1 factorial, and that's how we get the possible ways. So in this case, this means 6 factorial, right? That's 7 minus 1, which is 6. 6 factorial gives 720. Next question here says, for what value of n is n plus 1 combination 3 equal to 4 brackets n combination 3 close brackets? Now for this question, we're told that we have n plus 1 combination 3 equal to 4 multiplying n combination 3. We have to find the value of n. And so for what we need to do in this question is we need to solve separately, separately, and then we equate it. What does n combination r mean? It means n factorial over r factorial into bracket n minus r factorial. So that's what we are going to use to solve this. Here is our n, and so we have it as n plus 1 factorial divided by r, which is 3 factorial, into brackets n plus 1 minus 3 factorial equal to 4 into brackets n factorial over 3 factorial into brackets n minus 3 factorial. Now from here, what does n plus 1 factorial mean? If you have 5 factorial, what does it mean? It means 5 times 4 times 3 times 2 times 1. Or we could say that 5 factorial means 5 multiplied by 5 minus 1 multiplied by 5 minus 2 multiplied by 5 minus 3 multiplied by 5 minus 4. Alright? We could say that's what it means. And so we could use this approach to work this out. Now n plus 1 is the first one, which is like 5 here. So we have it on its own. That's n plus 1. Alright? Multiply by n. And then next, multiply by n minus 1. Because this is n minus 1 here. Or we could have said n plus 1 minus 2. So this is now n minus 1. We'll keep going. We have n minus 2. Now we'll keep going until we reach nowhere. So we can stop at factorial over here. And then we have 3 factorial multiplied by 1 minus 3, which is n minus 2 factorial. So you can see the idea behind stopping here, such that this and this would cancel out, right? So equal to this. Now let's take this and bring it here. So we have 4 into brackets. We'll do the same, we'll do likewise for this n factorial over here. What does n factorial mean? It will be n multiplied by n minus 1, n minus 2, and so on and so forth. So we have n into brackets n minus 1, n minus 2, n minus 3 factorial over 3 factorial, n minus 3 factorial. Now this would have gone on, like you can see I have n minus 4, n minus 5, but we decided to stop here such that this and this will cancel out. And so from here, this goes with this and this goes with this. We have n plus 1 into bracket n minus 1 over 3 equal to 4 into brackets n minus 1, n minus 2 over 3 factorial. Alright, so don't let us forget that this is a factorial here, so that's 3 factorial also. This 4 can multiply what we have here. Alright, so what this means is that n minus 1 gives us a value, n minus 2 gives us a value, right? So that means 4 multiplies this n, and this n multiplies the value that this gives us, which is n minus 1, and then it multiplies n minus 2 over 3 factorial. And then likewise is n plus 1, n, and n minus 1. And so from here, okay, we have over 3 factorial. From here, these 3 we could cross multiply, and when we cross multiply, let's leave only this 4 over here. So we have 4 left here, right? So everything here comes down, right? And then this 3 factorial comes here. So we have 3 factorial multiplied by n plus 1, n minus 1. And then we have this 3 factorial, which is this, and then this one has been moved, this 3 factorial has been moved up, which is what we have here. And so this over here comes down. So we have n minus 1, n minus 2. N cancels n minus 1 cancels n minus 1. 3 factorial cancels 3 factorial. Alright, so what do we have left? We have n plus 1 over n minus 2 equal to 4. This also cross multiplies now. So we have n plus 1 equal to 4 into bracket n minus 2. So we have n plus 1 equal to 4n minus 8. We collect like terms. So we have, let this minus 8 come here. We have 8 plus 1 equal to 4n minus n. Here we have 9 equal to 3n. And so n equal to 9 over 3, which gives 3. And so we have it that the value of n equal to 3. Next question here says, find the number of ways of selecting 8 subjects from 12 subjects for an examination. Right, so we want to select 8 from 12. We're not told to arrange it, so all we need to do is just to select. So that's a combination question. And so that's 12 combination 8. And following the formula, that will be 12 factorial over 8 factorial into brackets 12 minus 8, which is 4 factorial, right? So which is 12 multiplied by 11 multiplied by 10 multiplied by 9 multiplied by 8 factorial over 8 factorial multiplied by 4 times 3 times 2 times 1. 8 factorial goes, and then we have 4 times 3, that's 12, and then 2, we have 5. So we have 11 multiplied by 5 multiplied by 9, and that gives 495. So 495 is the number of ways. Next question says, in how many ways can 6 colored chalks be arranged if 2 are of the same color? When we have a question as such, we have 6 chalks and 2 are same. So what you need to do is that, now this question is asking for how we can arrange it. So it's a permutation question, right? Now what we have is going to be 5 factorial over 2 factorial. Since we have 2 of these that are the same, had it been we had none that are the same, we would have stopped at 6 factorial. And so in this case, we have 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 factorial over 2 factorial. And so 2 factorial cancels 2 factorial. And so we are left with this. And when we multiply this out, that gives 360 ways of arranging them. Next question says, Ralia has 7 different posters to be hung in her bedroom, living room, and kitchen. Assuming she plans to place at least a poster in each of the 3 rooms, how many choices does she have? Alright, so here we have Ralia, who has a bedroom, she has a living room, and she has a kitchen. And her choice is to place at least a poster in each of the 3 rooms. So meaning that, how many choices does she have? So she could place 1, 1, 1, 1, 1. In fact, she could have up to, that's 1, 2, 3, 4, 5, 6, 7. She could have it like this. So she could arrange it in different ways that she wants. So it's in about arrangement, in how she loves to arrange. And so in this aspect, we tend towards a permutation. And in permutation, we have 7 of the frames to be arranged in 3 rooms. And so when we have 7 permutation 3, that will be 7 factorial over 7 minus 3 factorial, right? And so 7 factorial, that's 7 times 6 times 5 times 4 factorial over 7 minus 3, which is 4 factorial. And so this cancels this, and we are left with 210 ways of arranging the posters in the 3 rooms. Here's the next question, which says, in how many ways can a committee of 2 women and 3 men be chosen from 6 men and 5 women? In this question, we have 6 men and 5 women, and we have to choose a committee where we have 2 women and 3 men. And so in this question, we have to find how many ways that we can choose them. In this, we have a combination question, which is 6 combination 3 multiplied by 5 combination 2. Now 6 combination 3 gives 20, and 5 combination 2 gives 10, which is 200. And so we have 200 ways of choosing this committee. Next question says, in how many ways can the word mathematics be arranged? Here we have mathematics, M-A-T-H-E-M-A-T-I-C-S. In how many ways can it be arranged? Now let's take note that we have some numbers that are repeating, and so we need to single them out. Why? We will know that if we pick this, it could have been this that we've picked. So we have M, which is twice, A, which is twice, and T, which is appearing 2 times. And so in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 alphabets over there. And so to solve this, we have it as a permutation question. Okay, so what we do is we have 11 factorial over 2 factorial times 2 factorial times 2 factorial. We're having two factorials here because of the repetition. And so in this case, when we have 11 factorial, that gives 39916800. Then 2 factorial multiplied by 2 factorial multiplied by 2 factorial, that gives 8. And so we have a final answer of 4989600 as the final answer. Now there are times whereby you could be given this in an objective as the answer, instead of bothering with long and big numbers like this. We have a next question here which says, in how many ways can the letters of the word flation be arranged? F-L-A-T-I-O-N. Taking a close look at this, we have no repetition of words. So we have 1, 2, 3, 4, 5, 6, 7. Number of ways whereby we can arrange this is 7 factorial, which is the same thing as saying 7 permutation 7, since we are just going to arrange it. And so 7 factorial gives us 5040 ways as the answer. We have a next question here which says, in how many ways can 6 people take places at a round table? B. How many ways are there if 2 people must sit next to each other? And C. How many ways are there if the 2 people must not sit next to each other? Now in this question, we have a round table, and we are told that 6 people are to sit on this table. There is no point of relativity or a relative position here, and so the first person can sit anywhere. The second person can sit on the left side of the first person or on the right side of the first person. And so because of that, we have 5 options for the second person, right? For the third person, he has 4 options, and so on. We have 3 times 2 times 1 until we are exhausted with the number of options. And so in the A part of this question, we have 5 factorial, and 5 factorial gives 120 ways of sitting around this table. The B part says that if 2 people must sit next to each other. Now, if 2 people must sit next to each other, it is possible that when we have 2 people that must sit next, so we have this. The first person sits here and the second person sits here. So how can they sit? Is it that they sit first person here and second person here, or second person or this person will come here and this person will come here? And so we have 2 ways, right? So that's more like saying 2 factorial multiplied by, we have 4 people left, and so the 4 people have 4 options left, which is 4 factorial. So the B part will be 2 factorial multiplied by 4 factorial. And so we have 48 ways by which they may sit down if 2 people must sit beside each other. Now the C part can be solved in 2 ways. If this is the number of ways by which the 6 people can sit, and if this is the way they can sit when 2 people must be together, what if when these 2 people must not be together? That will be 120, which is this, that is how they can all sit, minus when these 2 people are sitting together, which is 48. And so when we subtract this, it gives 72. Or, now if we are told that these 2 people must not sit together, what we may do first is simple. Let's arrange the remaining 4 people that are permitted to sit anywhere. So we can say A, B, C, D. Alright, so these people have how many? That's 4 factorial. These 4 people. Now, since they must not sit together, if we place 1 here, the second person now has 1, 2, 3. So which is 3 options where you can sit. That is 3. Now, not 3 factorial, which is 3. So we have 4 factorial multiplied by 3. That's 4 times 3 times 2 times 3. We have 72. So these are the possible ways of solving this question.